Assalamualaikum warahmatullahi wabarakatuh. My name is Raghid Muhammad Thareq, and I will be explaining the mini project for the computational intelligence. Today, I will be explaining my project title, that is Bank Marketing Prediction using Deep Learning Algorithm. So the objective uh, for this project is I chose this specific dataset in UCI machine learning. So firstly, the objective is to implement deep learning algorithm for predicting customer response to bank marketing campaigns. Secondly, to analyze large amounts of customer data using deep learning algorithm techniques for improved prediction accuracy. Thirdly, to identify the key factors that influence customer decisions in subscribing to bank term deposits through data analysis and modeling. And next, and lastly, to analyze the contribution of different features to the model's prediction and highlight the most influential attributes in customer decision making. So this is the workflow for this project. First, we collect the data collection or customer history, and then we pre-process the data and select the most relevant features for the deep learning model, and then deep learning model selection, and then train the model, select the data into the preprocessed data, and then lastly evaluate the data. So why we chose this algorithm instead of the other ones? Because the the for this project we need the ability to learn and model complex relationships within large data sets. So the chosen data sets will be the bank marketing from UCI machine learning. So in this dataset summary, we have 45,211 rows and 16 features. And then the target variable or the Y, which are the customer subscribe or no. And then after we pre-process the data, these are the missing values filled. So for jobs there are 288 missing, education 1,857 missing, contact 13,020 missing, and P outcome 36,959 is missing. So, what did I use for the model architecture for this algorithm method? So to predict whether a customer will subscribe to a long-term deposit, we implemented a deep learning model using TensorFlow's Keras sequential API. So there are the input layer, there's 16 features, uh, two hidden layers, and one output layer. So for the training setup, we use 30 epochs and 32 batch size, and the validation split we cut to 20% for training data used for validation and 80% for testing, and so on. So the summary of after the training, the accuracy increased from 0.88 0.8818 to 0.9183, and so on. And this is the training accuracy results. So the training log shows that the model achieved a convergence around epoch 20 until 25 with minimal differences between training and validation accuracy. So it demonstrates a good generalization. So here's after the test evaluation. So these results indicate that the model maintains strong performance on new unseen data. So the high test accuracy is 89.5%. So it confirms that the model has learned relevant patterns from training the data without overfitting. So the test accuracy is 89, 89.5 or 89, specifically 89.47%. So that's a high number. This is the visualization for the accuracy trend. And the next one is the loss trend, the visualization of the loss trend. And then this is the confusion matrix. So these are the predicted and actual for the yes and no. So we can see here that precision for class one or yes, 60% out of all predicted yes, so 60% were correct. So that is above 50%. Recall for class one, 37%. So the model only detected 37% of actual yes cases. And F1 score is lower than class 1, indicating room for improvement, possibly to do class imbalance. So that is it for my presentation today. Uh, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.